Assalamualaikum warahmatullahi wabarakatuh and greetings to all. Today our group will be presenting the non-destructive plastic in railway industry. Our group consists of 5 people, which is me, myself, Imran Jiha, Nurul Afrina, Nur Airi Nafisa, Siti Aisyah Zahira, and Siti Nur Amira. The contents of the presentation consists of 4 sections, which is firstly is the introduction, secondly is the analysis, we are discussing the importance, steps, and result, evaluation of the selected entity methods, thirdly is the suggestion, which to address the issue and improvement of the performance of component, and lastly is the conclusion. Introduction. With high speeds and enormous freight loads, editing on wheels is essential in keeping products and people safe. Non-destructive testing is the use of the sound, light, magnetic, and electrical properties without affecting the performance of the final product to detect whether there is a defect or non-uniformity, and also to determine the remaining life and quality control of the inspected product. NDT consists of a variety of analysis techniques for industries to evaluate the properties of materials, component, structure, or system. NDT methods can generally be classified into two categories, which is conventional and advanced. Each method has its own characteristics, advantages, and limitations. Our group have chosen ultrasonic testing, UT, for common methods, and phase-array ultrasonic testing, PAUT, for advanced method.
In railway industries, ultrasonic is the most common method used to detect defect on rails, and another important method that should not be underestimated is visual testing of rails. Visual inspection is the process of identifying the surface defects using naked eye only. However, it requires a trained inspector to perform this method, and the area to be tested shall be thoroughly visually inspected before any ultrasonic inspection is carried out.
For common method, we choose ultrasonic testing (UT). It uses high-frequency sound energy to conduct examinations and make measurements. Ultrasonic inspection can be used for flaw detection or evaluation, dimensional measurements, material characterization, and more. In the process, areas of the rail that are subject to faults can be checked through the various angles of incidence and probe heads. Here is the working principle of UT. A typical UT inspection system consists of several functional units, such as the pulsar or receiver, transducer, and display devices. What is the pulsar or receiver? It is an electronic device that can produce high voltage electrical pulses. Meanwhile, driven by the pulsar, the transducer generates high frequency ultrasonic energy. The sound energy is introduced and propagates through the materials in the form of waves. When there is a discontinuity, such as a crack, in the wave path, part of the energy will be reflected back from the floor surface. The reflected wave signal is transformed into an electrical signal by the transducer and is displayed on the screen.
Phase area ultrasonic testing, which is PAUT, probes are composed of several piezoelectric crystals that can transmit or receive independently at different times. It is to focus the ultrasonic beam. The time delay are applied to the element to create constructive interference of the wavefront, allowing the energy to be focused at any depth in the test specimen undergoing inspection. The phase area ultrasonic testing is quite similar with ultrasonic testing, but the only things that difference is the elements in the powered probes need to be same amount of pulse and receiver. For example, if the probe has 8 elements, thus it needs 8 pulses and 8 receivers. Each element will create signal wave and short delay between one of each other. This delay can be set up. The first basic working principle is angle control. Each element creates wave or signal, and later on, in a few seconds, the next element will create a signal or wave. It will continue until the last element. From this setup, we create angle wave in the component. The next is focusing. In this case, at the outermost two elements was create signal and then go inward until reach the middle. And we can see that wave is focusing at the center and is called as a focus wave. The last one is aperture control. This case does not use all elements but only use a subset elements from all elements and create smaller aperture with a bigger opening angle.
Now we move to reel profile. As we can see here is the illustration of the reel. The illustration of the right is the 3D model of the reel, which consists of three planes, which is the transverse, vertical, and horizontal plane. And the view from the transverse plane has been shown in the left figure. The parts in the reel which is head, foot, and web. In the head parts, there are fill sides which connect to the wheel track, and opposite side is the gauge side, and the upper side known as running surface. Next is the common defect that occur in the reel. The first one is the heat and web separation, which caused by the acid from some asphalt-based fillers used at highway crossings, which may start corrosion fatigues where the heat web parts. Fatigue can appear as rust-colored wheel streak in the heat web filler area, slight horizontal cracking under the heat, or a creep and wrinkle fillet. Next is the pipe reel. The origin is a wide longitudinal seam or internal oxidized cavity inside the web that comes from the manufacturing process. Once development starts, the seam develops vertically toward the head and base. Next one is the reel corrosion. Corrosion normally occurs in wet or damp areas such as tunnel or buried grid crossings. Essentially, corrosion is the rusting away of the metal, which shown in this picture. Besides that, the common defects occur in the wheel is the horizontal split head. The origin is an internal longitudinal seam, segregation, or inclusion from the manufacturing process. Separation progresses longitudinally and horizontally parallel to the running surface. A horizontal separation may be present in several locations within the same wheel section. Next one is the bowl hole crack, which normally the result of unusual stresses along the edge of the hole from the bowl itself. These stresses may be caused by pumping or swinging joints, improper drilling, excessively worn joint bars, or abnormal reel and impacts from rolling stone. Origin point may be stress contact between the reel and the bowl, or at a burr on the edge of the hole left by the drilling operation. Next one is the detail fracture from the welded bones, which due to a thermal cracks created by a rapid or irregular cooling at or near the point where the bone is attached, or the focal point of the defect is metallurgic reaction and the resulting penetration of the native metal through the martensite layer, sometimes developed between the bone and the wheel head. Now we move on to the common equipments used for wheel inspection. The first one is the ultrasonic single wheel flow detector, which can inspect single wheel at one time. Secondly is the ultrasonic double wheel flow detector, which can be seen at top right picture here, where it can detect the defects at both wheel at one time. And thirdly is the ultrasonic wheel testing truck, which also can inspect both wheels simultaneously.
For analysis, our group will discuss the importance of NDT in each phase of a material processing or in civil performance, steps or procedures of both common and advanced method, and result evaluation for defect rate. The ultrasonic inspection is applied on railway tracks primarily for detection and evaluation of internal rail defects, and it can be carried out either manually using portable equipment or special vehicles. The details of ultrasonic testing will be discussed in the following slides. Next, moving on to the procedures and steps involved in ultrasonic testing. There are four important steps. be followed in order to carry out this non-destructive testing on railway tracks. The first step is surface preparation and the second step is prop calibration. The third step is to conduct an inspection by placing the prop on the tested area, and lastly, the fourth step is the interpretation of results that will be done by a qualified inspector. This slide will explain more on the step in ultrasonic testing. Before any ultrasonic testing is carried out, the surface of tested area need to be cleaned from any irregularities. Meanwhile, the calibration of the ultrasonic probe is performed with the help of calibration steel block as the reference piece. Calibration helps ensuring the accuracy of test equipment, as accurate measurement is important in determining the quality of components and safety assurance. Next, the inspection is taking place using coolant to facilitate the transmission of ultrasonic energy from the transducer into the rail surface. A suitable frequency for a probe is selected to be able to detect the defect, and rail is inspected by placing the probe on the surface and move it over to the entire surface. The ultrasonic produce will covers the rail from the top of the rail head through the web to the bottom of rail and the entire width of the rail head. Finally, the result will be interpreted by highly skilled inspector for any flaw. Ultrasonic testing can be performed using two basic methods, which are pulse echo and through transmissions. For railway, the pulse echo technique is used and it will be discussed in the next slide. Now, let's move to the result evaluation of ultrasonic testing. The probe is positioned at a certain angle, detect the rail defect by using straight beam probe and angle beam probe with angles of 35 degrees, 55 degrees, and 70 degrees, as shown in figure A. The angle of the probe is selected based on the strongest signal from the defect of interest that it is able to scan. With pulse echo testing, the probe sends out and receives the sound wave energy. The sound wave travels through the material and are reflected back from the cracks and surface of tested area. Results are displayed as a line plot with amplitude on the y-axis representing the reflection's intensity and distance or time on the x-axis, showing the depth of the signal through the materials. As example, please refer to figure B and figure C, where it shows the signal of rail without flaw and rail with longitudinal horizontal split in head region using straight beam probe.
Every NDT method has its pros and cons. The advantages of using UT are high sensitivity, high penetration power, greater accuracy, non-hazardous, portable and highly automated, can be used when only one side of an object is accessible, able to estimate size, shape, orientation and nature of defects, and also immediate results, allowing immediate decision to be made. The limitation of using UT requires experienced technician, false positive results, objects that are rough, irregular shape, very small or thin, or not homogeneous are difficult to inspect, couplings required for tests that use conventional UT, and lastly, UT may have reduced sensitivity for volumetric flaw, particularly metal inclusion than radiographic testing.
Phase area ultrasonic testing, also known as PAUT, where this testing is advanced ultrasonic testing. All the setup, procedure, and data interpretation are more complicated that require a specialized understanding and experience from a properly trained technician. In this topic, we will discuss more details about phase area ultrasonic testing. Now we proceed to the step of procedure in PAUT testing. The first step is surface preparation, where we set up the component to be inspected. The second step is choose the right probe frequency according to the thickness of the component and set up the equipment. Step number 3 is where we position the probe on the component where we want to inspect. Step number 4 is fix the distance between the center line of the component to inspect with the probe front. After that, step number 5 is place the probe on the component and move slowly at the place to inspect for scanning. The last step is we observe on machine tools and analyze the result.
Following slide shows the phase array ultrasonic testing evaluation for the rail web. Flow measurement on the well is conducted on the rail head, rail web, and rail foot. The first picture shows the three modes of scan used in the phase array ultrasonic testing, which is the A scan, B scan, and S scan. Usually, we can use the S scan to locate the flaw. The picture on the right depicted the R scan view of the defect on the rail head. When the highest echo was found, we can measure the distance between the probe front to the hole center for the overlay position to find the flaw or defect. From the sectoral view of the R scan, there are three defects. The next picture on the bottom left shows the rail well with the presence of defect between 50 mm and 140 mm from the top of the rail. The last picture is the sectoral scan showing the bond line discontinuities that form the residual material on the base of the rail foot. There are several advantages of the phase array ultrasonic testing. One of them is it can be used to inspect the large coverage of surface area. This is because the probe uses multiple transducers which can assist in the inspection of the large surface. It also has higher accuracy and can provide the test result with an excellent repeatability factor. It has greater flexibility and requires less time because multiple inspections can be carried out with a single probe. As for limitation, the equipment should be handled by a trained professional to eliminate the risk of the inaccurate testing due to its multiple data optimization features. Other than that, this equipment can also have a higher initial cost compared to the conventional one due to its advancement.
Next is the importance of NDT in railway industry. The use of UT assures the safetiness of railway track. This method is sufficient to check the durability and maintenance of the tracks. Secondly, while using UT, we can prevent failure by analyzing the cause of deterioration, determine the lifetime of rail, and advise economical solution to the problem. Next is reliability of the testing. With this method, we can assess the current physical condition of the rail in order to determine its suitability for continued operation. Also, this method is cost efficient. It means that it can prevent undesirable accidents due to defects which led to replacing the item without destroying the test piece itself. Lastly, UT assure quality assurance by involving operational and maintenance for the rail to be frequently updated. Next, we will move on to suggestion. In this slide, we will address the issue and improvement of the performance of the structure, system, or component. So one of the issue of using UT is even though UT is good for detecting subsurface defects, but this method is poor in detecting surface and near subsurface defects. For the improvement, as many of the cracks appearing in rails are fatigue-induced and thus surface breaking, a combination of eddy current would prove most accurate and efficient in the detection of defects in a rail while the rail network is undergoing maintenance services. Another issue in UT is during high-speed inspection, the efficiency of current traditional UT probes in detecting small surface defects such as head checks and gauge corner cracking is insufficient, resulting in a high number of false alarms and hence longer inspection times and costs. Therefore, it is conventional to combine this method with preventive maintenance procedures such as head grinding in order to optimize the trade-off between maintenance costs and structural reliability. What is head grinding? Head grinding or rail grinding is a process to remove irregularities and restore the profile of the worn tracks to increase its life where railroad tracks that experience continual use are more likely to experience corrugation and overall wear.
In conventional phase array ultrasonic testing imaging, reflectors located outside of the focal region appear blurry. This is because the sensitivity in the focal zone is limited to a controllable that fixed depth in the inspected part. In order to improve the imaging, we can use the total focusing method or TFM. As for example from the picture obtained from an experiment, phase array ultrasonic testing image shows that the side drill hole or SDH located far from the focalization depth appear distorted and with a lower amplitude. Using TFM image, each one of the SDH appears with an optimal resolution.
In conclusion, the heavy haul of the rail operations such as in iron ore industries impose heavy demand on the rail material that will internally crack the rail track. Due to ongoing concern of the rail track failure as a result of fracture, non-destructive inspection procedures based on application of the ultrasonic and the phase array ultrasonic testing have been implemented. This preventive action will avoid the occurrence of serious accident and ensure the safety of the passenger. I think that's all from our group. Thank you.